MRI. So introduction. So MRI is nothing but magnetic resonance imaging. So it can uses magnetic field and pulses of radio wave energy to make the pictures of organs inside the body. Mostly MRI can be used to make the pictures of organs inside the body. Is mainly used in the MRI system. So MRI is nothing but magnetic resonance imaging. So in this we can use the magnetic field and pulses of radio wave energy to make the pictures of organs inside the body. So in many cases MRI gives different information about structures in the body. So then can be seen with an X-ray, ultrasound or computer tomography, that is CT scan. This CT scan, X-ray also produce the pictures of our organs. So MRI also may show the problems that cannot be seen with other imaging methods. So MRI is nothing but make the pictures of organs inside the body. This is the general definitions of MRI. So mostly we can use the X-ray, ultrasound or CT scan. So this also may also produce the problem that can be seen with other imaging method. This is the MRI system. Next, this is the block diagram of MRI system. So the block diagram consists of 4 coils, that is X gradient, Y gradient, power coil, Z gradient. So receiver coil. So here the interface, that is first one, the magnet and patients. The magnet is fixed near the patient, and the transmitter coil and receiver coil also placed. Here the transmitter coil receives the magnetic field and it will be connected to the RF power amplifier and transmitter. So here the RF power amplifier can be used to increase the signal strength of the magnetic signal, and it will be produce the RF generator. So this also connected to the interface. So the transmitter and receiver are also connected to the interface. So interface makes a connection between the computer and patient. So computer also produce the images of our organs in our body. So here the X gradient power coil, Y gradient power coil and Z gradient power coil also connected to the interface. So here the RF generator and the connected to the interface. So here the signal received coil also receive the signal from patient, and this will be amplified and it will be connected to the signal average. So this signal average connected to the interface. This makes a connection between the computer and human. So this computer also consists of signal processing unit, image storage and display unit. So here the signal processing can be collect the signal from computer and processing the signal and will be connected to the image storage. So here the image will be stored in the image storage and display the display unit. So here in this display produce the picture of organs in our body. So this is the block diagram of MRI system. So patient and magnet also placed into the patient, and also the signal will be transmitted to the transmitter coil and received to the receiver coil. The receiver coil produce the signal, it will be amplified and it will be connected to the signal average, and this will make the connection between the interface to the computer. So the computer consists of signal processing unit, image storage, display. So here the signal can be processing by using the signal processing unit and it will be connected to the image storage. In this image storage consists of pictures of organs in our body. So it will connected to the display unit. This is the block diagram of MRI system. Next, advantages of MRI over others. So others means CT scan, X-ray. Compared to CT, X-ray scan, it will be produce the advantages of MRI. So here non-invasive, high resolution, cross-sectional images available, yielding images that depends on physiology or functional properties, allow direct information about metabolic process in vivo, providing real-time imaging. These are the advantages of MRI. So it is invasive, high resolution, cross-sectional images also we can predict, and providing real-time images. This is the how we can take the pictures in our body. Means here the human inject to machine and produce the picture. This is the MRI scan picture. This is the internal organs of our human body. So if we take the picture, means this shows like. So next one, MRI parameters. So here three types of MRI parameters are available: spin density, spin lattice, that is longitudinal relaxation time T1, and spin to spin, that is transverse relaxation time T2. So this is the spin lattice relaxation time. So here in graph, the time constant that decreases the rate at which the Z component of net magnetism will return to its equilibrium value m0 is the T1 relaxation time, and this happens due to the excited nuclei transforming their energy to the surrounding molecular environment. So it is called lattice, and also it is called spin lattice or longitudinal relaxation. So this is the graph of spin lattice relaxation time T1. So here short time or long time. So TR is the longitudinal relaxation, is the respective time and signal. So it consists of short time T1 and long time T2. This is the MRI parameters: spin density, spin lattice, and spin to transverse relaxation time T2. Next, ultra. This is the spin lattice relaxation via molecular motion. So spin lattice T1, relaxation via molecular motion. So here electro of temperature, effect of temperature, effect of viscosity. So first effect of temperature consists of temperature T is equal to the green signal indicate the temperature T is equal to 280 K. The blue color indicate the temperature T is equal to 300 K. Pink color indicate the T is equal to 340 Kelvin. So the number of molecules versus effect of temperature. So this is the spin lattice T1, relaxation via molecular motion. So next one, the effect of viscosity with respect to the molecules. So here the green indicate the solid, and blue indicate the liquid, and pink indicate the viscous liquid. So here the T1 relaxation efficiency as a function of frequency is inversely related to the density of states. This is the spin lattice relaxation via molecular motion. So this is the MRI. So MRI can be used to predict the image in our human body. So it is also have the advantage over CT scan, X-ray scan, because it produces the internal organs of our image with good quality of image. Next, ultrasonography. So ultrasonography, here you use the ultrasound to. Ultrasound is a form of energy which consists of mechanical vibrations as the frequency of high above the range of human hearing. So ultrasound is the range of human hearing. So most biomedical applications of ultrasound employ the frequency in the range of 1 to 15 megahertz. So the velocity of ultrasound in soft tissues and bones are 1570 milli per second and 3600 millis per second respectively. So ultrasonic diagnostic aids are based on echo aspect. So ultrasound is a form of energy which consists of mechanical vibrations. So this is the range of above the range of human hearing. So the ultrasound diagnostic aids are based on echo aspect. So here it consists of Doppler shift aspect. So this is the The ultrasonic diagnostics are based on echo aspect, Doppler shift aspect, aspect, thermal effect, and cavitation effect. So Doppler shift effect, aspect, the thermal effect, cavitation effect. So cavitation effect is developed during the irradiation of ultrasound on the body. Next, the Doppler ultrasonic blood flow meter. So it is used to determine the flow of rate of blood in various blood vessels. How we can determine the Doppler ultrasonic flow meter means to determine the rate of blood in various blood vessels. And also it can cure the cancer and also used to detect the ordinary benign tumors. So this Doppler ultrasonic blood flow meter can be used to detect the cancer and also used to detect the benign tumors. So the ultrasonic bonding are useful to fix the fractured bones at their proper place in the body. So in the ultrasonic can also used to determine the flow of rate of blood in various blood vessel and cancer and ordinary benign tumors, and also used to fix fractured bones at their proper place in the body. Next, ultrasonography. So in this technique, ultrasonic energy is used to detect the state of the internal body organs. So in this technique, ultrasonic energy is used to detect the state of internal body organs. When this energy strikes an interface between two dishes of different acoustical impedance, reflections are returned to the transducer. So here transistor, we know the function of transducer. So transducer can be used to convert one form of energy to another form of. So here in this ultrasonic, the transducer converts this reflection into an electrical signal. So this echo signal is amplified and displayed on the oscilloscope at a distance proportional to the depth of interface. So this is the ultrasonography. So ultrasonography is a ultrasound. It produces some form of energy, that is the mechanical energy, to detect the state of internal body organs. So here the transducer converts the reflection to an electrical signal. So the echo signal is amplified and displayed on the oscilloscope at distance is proportional to the depth of interface. So this is the block diagram ultrasonic imaging instrumentation. So here it consists of transducer, computer, display unit and receiver. So in this, the computer makes the connection between the receiver, transducer and controller display unit. So here the transducer produces the position of data and connected to the receiver to the computer. So here front panel controls to the computer. So here the receiver, it connected to the signal processing unit. Here the signal is received from the receiver and processing that signal and connected to the image storage. So here the image will be stored. How we can get the images from our body. So this image will be stored in the image storage and finally displayed in the display unit. This is the block diagram of ultrasonic imaging instrumentation. So here computer make the connection between the receiver, control panel, display unit. So computer is consist of control the overall process of imaging system. Next, digital real-time scanner. So here the patient is connected to the probe and the receiver connect the signal from the patient and will be connected to the memory, that is CPU. So here the CPU also the receiver circuit or DGC circuit connected to the analog to digital converter and connected to the CPU. The CPU consists of memory and control unit. So the signal will be stored in this memory and this signal can be controlled and converted to the digital to analog signal, and this will be connected to the mixing circuit, and this signal will be displayed on the TV monitor. So if the body can be scanned and this image will be displayed on the TV monitor or computer display. So the digital real-time scanner. So when the patient is connected to the prop. This signal is received from the received circuit. This signal is connected to the, that is converted to the analog to digital signal and will be connected to the control unit, that is CPU, control processing unit. This CPU consists of memory and control unit. So here the memory, they store the image, and this signal is converted to digital to analog signal, and this connected to the mixing circuit. So here the synchronous signal will be generated. After that we can monitor. After that we can see the images in the TV monitor. TV monitor display the internal organs of our body. This is the real-time digital real-time scanner. So applications of ultrasonography. So ultrasonography is to find any brain tumor and also find any ultrasonic is to find any brain tumor and cancer. So the ophthalmology used to find foreign objects in our eye. So cardiology used to determine the cross section of the heart and to determine the heart rate. Gynecology also used to monitor the fetus growth and to indicate the presence of twins. So these are the applications: ultrasonography, ophthalmology, cardiology, gynecology. So ophthalmology used to find foreign objects in our eye. Cardiology used to determine the cross section of the heart and to determine the heart rate. Gynecology used to monitor the fetus growth and to indicate the presence of twins. These are the applications of ultrasonography. So these are the explanation of MRI and ultrasonography. So MRI is nothing but magnetic resonance system. So this can be used to detect the images in our internal organs of our body. So ultrasonography also used to find any disease available in our human body by using the ultrasound, that is the mechanical energy. This is the MRI and ultrasonography explanation.